By the end of this video, I'm going to hand you a single spoonful of something that outweighs every human being on Earth, combined. I won't explain what it is yet. You'll have to stay for that. First, we're touring planets that break the rules of physics, riding along with astronauts doing things that shouldn't be possible, and standing at the very edge of everything we actually know about the universe. 15 facts, every single one real. Let's go. We start close to home, with planets that are, frankly, showing off. Here's a question. Is there a planet in our solar system that would float in a bathtub, if you had a bathtub big enough? There is. Saturn is so light, despite being enormous, that its average density is actually lower than water's. Almost the entire planet is made of hydrogen and helium, the two lightest elements that exist. So picture it, a tub the size of several Earths. Drop Saturn in. It wouldn't sink. It would just float there, rings and all, bobbing on the surface like a beach ball. It's the only planet in the solar system that could pull off that trick. Saturn's not the only planet breaking the rules. Two more. Quick one. What happens on a planet where the day is longer than the year? You're standing on Venus. It spins so slowly, once every 243 Earth days, that it takes less time, 225 days, to loop the entire sun. One day outlasts 1 year, and it spins backward. Another one, how much of the solar system is actually just the sun? 99.86%. Every planet, moon, asteroid, and comet combined, Jupiter, Saturn, Earth, all of it, barely register as a rounding error. Now here's a question for you. What's the biggest mountain you've ever seen a photo of? Because you're about to feel very small. What does it take to build the tallest mountain in the entire solar system? On Mars, the answer is disturbingly simple. Never let the ground move. Meet Olympus Mons, a volcano about 624 kilometers wide and 25 kilometers tall, roughly 3 times the height of Mount Everest, with a footprint the size of the entire state of Arizona. Here's the part nobody mentions. Mars didn't necessarily have bigger eruptions than Earth. On Earth, tectonic plates slowly drag a volcanic hotspot along underneath them. That's why Hawaii is a chain of islands, not one mountain. Mars has no moving plates. The crust just sat there. So the same volcano kept erupting in the same spot for millions and millions of years until it became the biggest mountain in the solar system. And if a mountain that size doesn't impress you, maybe the weather will. What if I told you it rains diamonds on 2 planets in our own solar system? Deep inside Neptune and Uranus, the pressure is so extreme it rips methane molecules apart. Hydrogen goes one way, carbon goes another, and that leftover carbon gets crushed into diamond crystals. Real ones. They sink, like rain, all the way down toward the planet's core. Scientists didn't just guess at this. They recreated the exact same crushing pressure in a lab here on Earth and watched diamonds form in real time. Somewhere on Neptune, right now, there's a diamond falling that no one will ever pick up. So what could possibly be stranger than diamond rain? Try metal rain. 636 light-years from here, there's a planet called WASP 76b, where the day side gets hot enough, north of 2400 degrees Celsius, to vaporize solid iron. Winds screaming at 18,000 kilometers an hour then drag that vaporized metal across to the planet's night side, where it cools, condenses, and falls back down as liquid iron rain. Europe's PAYOFF satellite even caught a rainbow-like shimmer, called a glory, glowing in that planet's atmosphere. It is, quite literally, raining metal, 636 light-years from where you're sitting right now. Our own solar system is strange enough on its own. But the strangest things in space aren't always the planets. Sometimes it's the people we send to visit them. Let's follow the humans. How many sunrises do you think you'll see today? 1, probably. Astronauts on the International Space Station see 16. The ISS circles the entire planet every 90 minutes, flying at about 17,500 miles an hour, roughly 250 miles above your head right now. Do that math, and every day up there is really 16 sunrises and 16 sunsets, on a loop. Quick gut check before this next one. How do you think astronauts get their drinking water, 250 miles from the nearest tap? Here's the part nobody wants to think about. NASA's life support system on the ISS recovers about 98% of all the water on that station. It condenses their breath. It filters their sweat. It distills their urine. And it runs all of it through the system, again and again, until what comes out the other end is measurably cleaner than most tap water down here on Earth. So yes, days earlier, that drinking water was sweat, and it was urine. It's not gross. It's just extremely good recycling. Down on the moon's surface, there's something that hasn't moved in over 50 years. Neil Armstrong's and Buzz Aldrin's boot prints, still pressed into the dust exactly where they left them. There's no wind on the moon, no rain, no atmosphere at all to erode anything, so those impressions in the dry lunar soil are essentially frozen in time. NASA's Lunar Reconnaissance Orbiter has photographed the old Apollo landing sites from orbit, and the footpaths are still clearly visible decades later. Scientists estimate they could still be there in 10 million years. And the moon itself isn't exactly staying put either. It's drifting away from Earth by about 3.8 centimeters every year, roughly the speed your fingernails grow. Every centimeter it drifts, it steals a tiny bit of Earth's spin, which means, technically, your days are getting longer, one imperceptible fraction of a second at a time. If footprints can survive being left on the moon, you'd think nothing could survive being thrown into space itself with no protection at all. You'd be wrong. In 2007, the European Space Agency did something that sounds almost cruel. They took microscopic animals called tardigrades, water bears some people call them, dried them out, and fired them into orbit with no protection at all. No spacesuit, no capsule, just open vacuum, freezing cold, and raw cosmic radiation for 10 days straight. Some were even hit with direct solar UV rays, the kind that would kill a human in seconds. And when they came back, most of them were alive. Some went on to reproduce completely normally, as if a 10-day vacation in the vacuum of space was nothing at all. If any creature is going to outlive the rest of us, it's probably a half-millimeter animal you've never heard of. We've toured the planets, and we've followed the astronauts. Now let's go all the way to the edge of everything we know. Quick question. How old is the sunlight hitting your skin right now? Most people say 8 minutes. And that's true, technically. Light does take about 8 minutes and 20 seconds to cross the 93 million miles between the Sun and Earth. But here's the part nobody mentions. That same light spent a lot longer than 8 minutes just trying to leave the Sun in the first place. Deep in the Sun's core, photons get created, absorbed, and released again, bouncing around that dense interior for tens of thousands, maybe hundreds of thousands, of years before they ever reach the surface. The 8-minute trip to your skin? That's the easy part. It's the way to get out of the Sun that takes several lifetimes. Here's a question. What's the oldest machine humanity has ever built that's still doing its job? From 25 billion kilometers away? In 1977, NASA launched a spacecraft called Voyager 1. It never really stopped. It is still out there right now, the single most distant object humans have ever built. And it is still transmitting data back to NASA's Deep Space Network, nearly 50 years after it left Earth. And now, the thing I promised you at the very start of this video. Remember that spoonful? Here it is. Somewhere in our galaxy right now, there are collapsed stellar cores called neutron stars. The leftover hearts of dead stars, crushed down into a sphere only about 20 kilometers wide, roughly the size of a city. Packed inside that sphere is more mass than our entire Sun. NASA's Keith Gendreau, who studies these objects for a living, describes the density like this. Imagine taking Mount Everest, the whole mountain, and squeezing it down into something the size of a sugar cube. That's what we're talking about. And here's the number I promised you. A single teaspoon of a neutron star would weigh about 1 billion tons on Earth. Not a ton. Not 1,000 tons. 1 billion. One spoonful, heavier than every human being on the planet combined. If that number just rearranged how you think about the universe. Here's the last thing, and it might be the most important one in this whole video. For over a decade, NASA's Hubble telescope data told us something we treated like settled science, that our galaxy, the Milky Way, was on a collision course with the Andromeda galaxy, due to collide head-on in about 4 billion years. It was in the textbooks. It was treated as fact. Then, in 2025, scientists went back with better data. an updated combination of the Gaia mission and Hubble, and the odds changed completely. It's now closer to a coin flip. Roughly a 50% chance of any collision within the next 10 billion years, and only about a 2% chance of a true head-on hit in the next 4 to 5 billion years. Even the facts in this video, the ones backed by NASA and ESA, give it a few years and better instruments, and some of them might change too. That's not a flaw in science. That's the entire point of it. 15 facts. Every single one sourced straight from NASA or the European Space Agency. Links to every source are in the description if you want to check my work. If any of this rearranged how you think about space, subscribe, because we do this every single week. And tell me down in the comments, which one actually got you? The spoonful, the diamonds, or the metal rain?